We've been there before. The last time we visited the moon, we brought everything with us. We landed, planted the American flag, took some pictures, did some experiments, explored, and then we left. It's been 50 years, but we're going back. Not to visit, but to stay. To establish the first permanent human settlement on the moon. A waypoint for human exploration, to reach even further destinations, like Mars. To do this, we need to build the infrastructure, the partnerships, relationships with businesses and people necessary to continually move supplies across vast distances, from the Earth to the moon. For this mission, NASA is seeking your help. Since we last visited the moon, we've continued building and learning, reaching new heights in space technology, astronaut health, and module durability and longevity in a challenging environment. For the past 20 years, we've lived here, and now we want to go here, and even here. Accomplishing these goals will require more durable and complex systems that don't yet exist. Because the moon and Mars are so far away, we won't be able to communicate in real time with the people or the hardware going there. That means that we'll need autonomous systems capable of making decisions for themselves. Batteries that last longer, charge faster, and weigh less. With interactivity between robots that has never before been accomplished in space. That's where you come in. Today, we can order something online, have it delivered next day. It takes an incredible system of cataloging, tracking, inventory management, and automation to accomplish such a simple task, thousands of times each day. Although next day delivery can't happen on the moon, we want to partner with you in developing existing capabilities on Earth and translating them to the logistics supply chain beyond our atmosphere. The challenge with delivering things to the moon isn't just a question of speed. I mean, rockets need to be loaded days in advance. May sit on the pad for several days more while waiting for an appropriate launch window. No, it's also a question of durability, accountability, and automation. You see, space is challenging, not just in terms of cost, but also because it's bombarded with radiation, which induces rapid changes in temperature to vulnerable payloads, and is filled with things moving very, very fast. In terms of logistics, this introduces an entirely new range of variables. How do you quantify and ensure delivery success for products to the moon? How do you handle logistics to the launch pad on a large scale? How do you manage deliveries on the lunar surface or between modules in orbit? In many cases, there won't be people there to handle these products, check inventories, or fix problems. In the case of a delivery to the moon, there is a delay of 2.5 seconds, so remote control is difficult. For Mars, the delay increases to 40 minutes, so remote control will be impossible. At NASA, we've worked hard to develop autonomous systems that can perform basic problem solving. This summer, we launched the Mars Perseverance Rover, which will arrive in February at the Red Planet. This mission required 2.5 million lines of code, with additional lines attributed to machine learning algorithms for terrain navigation. That was a challenge, but it doesn't end there. We've been working to develop automated guidance systems that ensure our automated spacecraft can dock by themselves over 200,000 kilometers from Earth. These systems are the same ones that can be expanded to automated logistics here on Earth. Recharging electric trucks without stopping or connecting segments of cargo for delivery on rail. Imagine the possibilities if suddenly your cargo could deliver itself 24 hours a day, 365 days a year. Our work with international partners to pioneer robotics on the International Space Station was a necessary first step to overcome the challenges of loading in zero gravity. But those are challenges you've already faced and conquered here on Earth to navigate the world of warehousing and distribution. The additional challenges faced by deep space logistics have direct applications to optimizing navigation of multi-agent systems and the storage and retrieval of large, densely packed, and heterogeneous cargo. So who does this supply chain benefit? Why does it matter? Today, we're an increasingly global and interconnected society, interacting with cultures and commodities from across the world. Trade and the transportation of goods is something humankind has been doing since we first began exploring Earth's vast oceans. And speed has always been a vital component, especially with today's economy. Not only for the delivery of consumer goods, but also for the transportation of perishable goods, or more urgent concerns like the medical supply chain. Increasing the speed of our logistics supply chain is essential to driving down costs. These technologies will enable people to focus more resources where it matters most. Increasing the speed of our supply chains will continue to open up new ways to live and think about consumption, improving how we utilize our finite amount of resources together, globally. And we're reaching out to you because this isn't something that NASA needs to do alone. The experience and means to improve our methods is likely right here at this event. In addition to the algorithms and computer science needed to improve deep space logistics, there's also the question of packaging and delivery. Not only to handle the extreme environment of space, but also to consider what happens when it arrives at its destination. Here on Earth, and especially within the past 100 years, we have become accustomed to the concept of disposable and single-use packaging. This practice has damaged our environment by filling landfills and oceans, and we're just now learning how to deal with this problem. Part of the challenge of logistics is engineering the right kinds of packaging and delivery methods to not only ensure that your cargo is delivered safely, but also responsibly. These packages should be affordable and, when possible, reusable. This is another problem that is compounded by spaceflight. For space travel, cargo needs to be protected from a harsh environment, which includes radiation that damages electronics, temperature changes that spoils food, and depending on the mission, G-forces several times that of Earth's normal gravity. Space cargo also needs to be lightweight enough to make the delivery affordable, disposable, or reusable upon arrival. NASA's been working on that. On the International Space Station, we have developed advanced systems to reuse wastewater and produce oxygen for breathable air. Though there is currently little reuse or recycling of spent items or material waste. Instead, astronauts load trash into departing spacecraft for disposal that burns up in Earth's atmosphere. We can do that because as far as space exploration goes, the space station is close by and relatively easy to access. However, on long-duration human exploration missions outside of low Earth orbit, there won't be easy access to departing spacecraft to remove waste or take out the trash. Waste equals volume. Spacecraft designed to ferry astronauts have very limited space to also carry along things like used uniforms, food packaging with residue still in it, hygiene items, and other trash. We will need a separate vehicle to transport all the material cargo. Additionally, everything launched into space requires propellant to get it there. Sending cargo beyond low Earth orbit takes increasing amounts of propellant to get it to places we want to explore, like the Moon and Mars. So at Kennedy Space Center, we've developed a system called OSCAR, or the Orbital Syngas Commodity Augmentation Reactor. This technology uses heat, oxygen, and steam to transform old clothes, food packaging, and even human waste into a mixture of gases to be safely stored, reused, or vented harmlessly into space. We can then take those gases and turn them into useful products like propellant. OSCAR is one part of a larger effort by the agency aimed at reducing and repurposing waste. Designing packaging that fits within the capabilities of OSCAR is a challenge, but it's a challenge that we believe you are capable of meeting. This isn't entirely new. Your industries have developed new packaging technologies based on affordability, demand, and the environment. This sort of adaptability and innovation is a necessary ingredient for the next steps in furthering that technology. And did we mention that this technology isn't just good for NASA? NASA shares some of the same basic goals for logistics cost reduction and reuse that many of you have. Reducing the amount of logistical mass, improving the tracking of items in packaging containers to allow denser storage, reduces the time we spend handling the items. Reuse and repurpose, while also assigning secondary purposes to packaging. Takes those materials and recycles them into something useful that helps you accomplish your goals. It's good for you, it's good for the environment too. Each time you reduce your packaging, you're saving money, shipping more, and wasting less. Understanding logistics requirements such as reuse and recycling and effective planning are critical to successful long-duration human space exploration. Okay, so we've talked about automation. And we've talked about packaging. There's one more key technology where NASA could use your help: the supply chain. Many of you are experts at managing elaborate, complex supply chains and have used technology to help reduce costs and improve efficiency. That methodology, honed through decades of experience, will also have applications to our deep space supply chain. And this will all be happening in the very near future. To accomplish this will require us to overcome many challenges. Just-in-time delivery might not be an option when delivering to the moon, and with current technology, certainly isn't feasible when talking about a Mars mission. Still, we're confident we'll meet these challenges because we have the talent and experience in this industry to do it. How do you ensure delivery of equipment to Mars when the next delivery window is 2 years away and the trip takes no less than 6 months? How do you accommodate rapidly changing demand with such a large delivery time? How do you meet the guidelines of planetary protection and sanitation at every step along the way? From the organizational perspective, how do you define interoperability standards between your cargo and NASA or other commercial and international partners? How do you define roles and responsibilities across vast dimensions of time and space? These are just some of the challenges we will need to solve in the next 10 years. But NASA doesn't want to do it alone. We can't do it alone. There are opportunities for investment, innovation, and growth far beyond the boundaries of this pale blue dot we call home. At NASA, we recognize the value of diverse perspectives and experience, which has always fueled creativity and innovation. This includes cooperation with government, private, and the commercial sector, all of which will be essential for the opportunities and challenges ahead. At NASA, we're going.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources.
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity.
In a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
Welcome back to the launch desk here at FreightWaves. I'm Dooner with Michael Vincent, and we just saw a really awesome keynote from our guest right now. It is Mark Wiese. Mark, anytime you talk, I listen.
What's going on, Dooner? Vincent, great to see you guys.
Great to see you, Mark, again, since we saw you earlier this year in person. Can't wait to see you again in person, maybe at a launch sometime.
Yeah,
right?
one of these days. One of these days we'll get down there. Mark, tell me a little bit.
We're prepping for one today. We got a cargo resupply to the space station sitting at the launch pad right now, ready to go.
Oh, beautiful. What time is that taking off?
So today is just a hot fire. We're prepping for it, so it's coming up here in a couple days.
So, Mark, let me tell you, let's just, before we move on to Q&A, just tell me a little bit about what went into that keynote. Why did you want to deliver that to this audience? What kind of message did you want to convey?
Yeah, no, so thank you, and thank you to this whole FreightWaves audience for watching us. We're really changing our model here at NASA. We're moving to buying a service, trying to really work a lot harder to incubate across commercial sectors. You know, NASA's the R&D leg for the federal government, and you know, we go do things that don't make business cases close and try to prime the pump there, but we're getting to this place in space now where it's opening up to markets all over the place. So it's time to start moving towards the commercial sector where they can see a place where businesses can close. And we want to inspire that in non-traditional industries. And the logistics area is prime and ripe for that.
Wow. Well, I know that we have a lot of questions. Should we get right to them? I know you brought a couple friends with you, Mark.
So I got with me Mark Mcdonald. He is our chief architect at NASA for the Space Technology Mission Directorate. So spends a lot of time on incubating, you know, the technology we got to go buy down to do our missions. And then also with us is Max Bridges. So he's the program executive for this new thing we call iTech. And he'll talk about that a little bit. It's a great area where we're also working on the venture capital side and trying to connect the dots where private investment wants to go make something happen in industry that'll work for us as well.
Well, welcome to the show, gentlemen. We're glad to have you here at FreightWaves. Actually, our first question is a really easy one. You guys don't even have to answer this one. It comes from someone named Craig Fuller. He says, how do I get a FreightWaves shirt? You go to, he's modeling it right here, Michael is. You go to swag.freightwaves.com. Now, guys, the first question here actually comes from John Gallagher. He said, what's NASA's role in overseeing the space industry compared to that of the FAA, and to what extent do the two agencies work together?
Yeah, so FAA is a regulatory agency, right, that makes sure rules are followed and rules are enforced. And NASA's more on the leading edge, the technology edge, trying to open up the door so other players can come on board. And FAA is actually playing in the space industry now. The FAA actually helps with the commercial launches. So we work hand in hand and partner as things move from a research area to an operational and commercial area where industry is involved.
Nice. The next one comes from Geek Gearhead, and he says, what do lunar station operations look like? So he's kind of wondering what goes on in there, what's the back end, what's the logistics of it all?
Yeah, so space station is the great analog, right? Our low Earth orbit research platform that's pretty close to home. And we have constant operations there, 20 years now, where we've had a continual human presence. And we bring up cargo half a dozen times a year to space station. When we move out to the moon, we're going a huge leap beyond, you know, from 200 miles above Earth to 250,000 miles away. And we've got to go operate independently, autonomously. We won't have a crew there 24/7. So it starts to change the game a little bit. We're not always there, and we have to think ahead and plan for something that's a lot further away.
Excellent. So Seiko Logistics asks, with the privatization of inner orbit, what will space waybill look like? A space waybill look like, and can we help create one? So how do they get involved?
So that's an interesting question, right? So there's a lot of logistics we line up, and all the things we have to document in our manifest and what we're going to fly. We work hand in hand to make sure we supply the science that'll go up there, we supply the astronauts' needs, and we'll do the same thing out to the moon. But we're already working with commercial industry. There's a contract out there that NASA let a little over a year ago called the Commercial Lunar Payload Services, where we're partnering with industry for them to take our instruments. So what that waybill is going to be NASA science instruments going on commercial landers where they can deliver that straight to the moon. So we're trying to prime it all over the place in different areas, not just for our astronauts, but for the independent research side, and really start to open the door for how we can move things beyond Earth orbit.
This one is for Max Briggs, who has just an amazing NASA name right there. I love that one, Max Briggs. And the question is, what is the TAM of space, and how do venture capitalists get involved with investing in space? What does that market look like?
Oh, so the TAM in space is a really it's one of your unknown unknowns, right? You're not going to be able to answer that right now. I mean, some people kind of try to. Neil deGrasse Tyson says all the time, the first trillionaire is going to be somebody who brings back rare earth metals from an asteroid, figures out how to do it quickly, and so I mean, there's certainly people that believe that there's a huge TAM in space, but I think that, I mean, there's also the possibility of, I've heard people talk about GAM, the government addressable markets, right? So there's things that are commercially viable, but there's also the potential to provide commercial services to governments as well as other commercial entities. And so that's a decent amount of what we do for iTech is try to, which is the program that I've been involved in most recently, is to try to get people to try to, as Mark said earlier, prime the pump, to try to get identify markets that are going to be useful for both commercial industry as well as for governments. And so that we have different programs to address different things. And so sometimes the other program I was involved in is called Small Business Innovative Research. And that is focused more on kind of low to mid-level TAM, where maybe a venture capitalist needs to reduce the risk a little bit more before they're willing to get into it, because it doesn't have the huge unicorn bang for your buck kind of thing. But then in iTech, we actually we go to the VCs and we say, hey, look, what are the things that NASA is interested in that also have a huge total addressable market for you? And so, there's obviously tons of things in low Earth orbit commercialization, in Earth science observation. There's all kinds of things, weather. There's all kinds of things that you can go and do there. But to put an exact number on it, I mean, we are in the very early stages of figuring. It's like asking somebody what the TAM was on airplanes when the Wright brothers started flying. People had no idea what was going to happen. So, it's really unknown at this point, but we know that there's potential. And what we're trying to do in both iTech and SBIR is explore that potential and, make sure that accelerate the actual, viability of that market.
Mark Wiese. Mark, how long until we see freight runs to Mars?
Yeah, so right now, Gateway is that, getting us at the moon so we can practice to go to Mars. So within the next decade, we're looking to have that permanent human presence at the moon, set up the right infrastructure so that we're practicing at that planetary body closest to us. Mars is the next big leap. But you heard Maxwell, make the analogy of the Wright brothers, right? Everything's accelerating. So we're hoping to get to Mars in the 2030s. And hopefully we got Mark Mcdonald back. He's focused on that government side of how do we buy down the gaps that'll get us to Mars.
So there's a lot of comments about, and you mentioned, I believe it was Oscar, and I can't remember exactly what that stood for, but you talked about, there's a lot of comments about how you're being responsible about trash and looking at waste and that type of stuff, and some comments in there about turning waste into fuel. And then some of the questions are, can we use the waste on Earth to produce that fuel and reduce our landfills and the recycling here on Earth?
Yeah, that if we can get the launch costs down, right, maybe there is a way for us to start reducing the waste we have here on Earth, because we can start moving some of that stuff off. and the technologies we're doing to try to recycle. That's what Oscar's helping us do, recycle things that we send up to orbit so that we can repurpose them. If we can do that, we're finding ways to reuse that. That technology is going to move back down to ground here as well. And that'll be ways for us as a community, to take the Back to the Future images we have as a kid where they're throwing garbage in the DeLorean and turning something into useful for us here on Earth.
I guess the follow-up question to that would be, can't we just launch all the plastic up into space? I think that was actually the plots of Superman 4.
So there, pyrolysis, and there are several different processes that are being looked at to try to be able to convert plastics and general waste into high-quality jet fuel or rocket fuel. So that's definitely being looked at, and it's it's a matter of the commercial viability at this point. Trying to scale it, trying to get the business case to close. But if you can go ahead and take and get paid for a feedstock that you can then sell, then if you can make that business model close, that's definitely being considered at several. There's a few different players in that game that are trying to develop technologies to do that. So it goes from offshore, putting a plant out there by one of those garbage islands, in the ocean, or going right next to a facility that produces a lot of waste products that you can just directly put into your feedstock and then use it for jet fuel.
Excellent. So here's a question. What is NASA doing today where the ground logistics industry can play, and how do they engage with you?
Yeah, so if Mark can take this one, there's a lot of challenges that NASA's doing, so I'll let him expand on some of that if we've got him back.
I just got back. Sorry for the chief architect for technology having technology problems.
Welcome to 2020.
Yeah, it happens. It happens. So there's lots of ways for the ground logistics industry today to help out. First off, it's your operational knowledge of doing this every day. You're going to have ideas of things that could help you do your job today that will also help us in the future. So those ideas of when you sit there at night and you say, gosh, I wish I had, well, that's the idea we're looking for, because that can spawn a technology that can be commercialized both to help you and to help NASA in the future. So we want to hear those ideas and help develop those technologies so that we can prepare for the future, for the space, and enable the commercial market on the ground.
Now, Mark Mcdonald, as a follow-up to that, what's the bigger challenge? Is it the regulatory side or the technological side? Where do you need the bigger breakthroughs to come in?
Well, it's definitely the technology side. Regulatory, there was a question earlier about the FAA and regulations and NASA's appropriations. The government's actually leaning forward quite a bit, more so than I've ever seen in my career before, to enable companies to do the right thing, to get these missions flown for the country, but also to be able to make a profit while doing it. You need to look no farther than SpaceX, Northrop Grumman flying logistics to space station today. It's happening. People are doing it. So regulatory is not a problem. Technology, it's the same thing in the ground industry. The more efficient you can make your trucks, the more profitable you become. We need to make our transportation thing more efficient. The ability to get mass to those distances. And the one thing I would point out is the biggest difference between the Apollo program and the Artemis program is logistics. In Apollo, we could only take what we could carry on that one mission. In Artemis, we are planning a logistics trail, right? That's what's going to enable a sustainable marketplace to keep us going forward.
Yeah. So, Mark, another question for you really is, you talked about, let's dig a little bit deeper into the logistics. Mark Wiese mentioned, inventory and delivery and warehousing and the remote control aspects of the supply chain throughout space as you hit the moon and then beyond. Talk to some of those challenges there. How do you do that in such a deep freeze environment? And the time delays, I think 40 minutes to remote control something on Mars, and what is it, 2.5 seconds to the moon?
It's both harder than you would expect and easier than you would expect. All right. The environment is incredibly cold in the places that we're going to on the moon. Literally, they're so cold that atoms stop moving in some places. it's really cold. So if you picture, using an analogy in your industry, but ice truckers, where they have problems in those cold environments moving logistics, the same thing's going to be true here. So it's getting the new materials, getting the equipment to operate in the environment will be challenge number one. The autonomy is thinking ahead in advance. We have automated forklifts on the ground today, automated logistics facilities that will go and get things out of your warehouse and bring them back. Those types of things already exist. We're going to be doing those same things in advance. If you think about that automated warehouse, you set it up to work automated. You design it that way from the front. You have signs and markers and sensors such that the automated robotics know where to go and know how to operate. We'll be doing the same thing on Gateway and the same thing on the surface of the moon.
Wow, fantastic. Hey, Mark Wiese, let me ask you a question. Did you place the obelisk in Utah? And how do you feel about when aliens, NASA get memed and about some of these conspiracy theories?
So we may have it here on Kennedy Space Center soon, but I think it's great because we're opening the door for more fans, right? We talk about the science fiction aspect and science reality that we happen to be stepping on and crossing the border of. So it's outstanding when we can just encourage and inspire more folks out there to get excited and see how fast technology is accelerating, how close to home the things NASA's doing, and that they're investing in as taxpayers really does impact them.
We have a viewer question here from David H. How long do you believe it will be before we see same-day global delivery powered by rockets? He follows it up. Obviously, would be only feasible when payload is life and death or extremely valuable, but it's interesting new mode of transportation.
So for me personally, NASA's investment going back to the moon is because we're seeing advances in reuse and in rocket technology. We're seeing costs come down. We're seeing additive manufacturing. We're seeing miniaturization again of electronics, really bringing us closer. If you look at the investments NASA has made in the big SLS rockets and advanced manufacturing, that's already playing forward in companies like SpaceX and Blue Origin, where they have now taken our reusability of the space shuttle and turning that into returning booster elements right back to Earth. The U.S. Department of Defense Transportation Command recently, set up a study that they're doing with SpaceX. When you look at systems like their Starship Heavy Lift, you look at Blue Origin's New Glenn vehicle, the ability to move cargo high speed point to point isn't that far off. It might be in the next decade, it might be right beyond that, but we're getting launch costs down. We keep pushing it down. We're working on the safety aspects continuously. The frequency is increased tremendously, and you'll start to see what we can do with rocket technologies start to open up ideas for options when we need to do things fast. We've got this logistics supply chain that we're all waiting on with vaccines for COVID here pretty soon. Some of them got to be kept at temperatures. You heard Mark talk about the extreme environments on the moon. You start to see how all these things start to cross. We've got smaller rockets now launching that we didn't have before. It used to be all about economies of scale and large rockets. Now we've got smaller ones. So things are moving fast, and it might be another decade, but it's coming.
Max, we just have about
real quickly there. I used to manage the Aeronautics Research Mission Directorate's SBIR portfolio, so I'm obligated to remind everybody that the first A in NASA is Aeronautics. And so there's a ton of logistics and delivery and freight potential in drone delivery and things like that. So getting things to people rapidly does not necessarily have to happen with rockets in order to be NASA relevant. So if you guys have solutions that you think apply, there's whether it's SBIR or ITech or Fed BizOps or broad agency announcements, you guys may have solutions that are NASA relevant, even if it doesn't involve putting something on a rocket.
Wow. I wish we had another 2 hours to just keep fielding questions to you guys. We didn't even get to even a fraction of them. So we'll have to get together and do this again, hopefully before even the next SpaceWaves. What is, we have about 1 minute left. What's next for NASA to get people excited, Mark Wiese?
So soon here, we start to hear astronauts that are going to get announced and selected for Artemis missions. We're looking forward to hearing where that goes. We're working on international partnerships as part of Artemis. Recently, made the announcement with the European Space Agency. We're looking forward to some more coming on board. The Artemis Accords were showing broad, on the regulatory side, broad cooperation across the world. So coming up in the next year, we'll start to see the next steps we're taking to enable Artemis.
Mark, and Max, thank you very much for your time today. We really appreciate it.
Thank you.
Appreciate you doing this. Thank you.
Excellent
Thanks.
stuff.
Take care. Wow. Like I said, we could have just kept going on and on, but we can't. You know why? Because the new frontier doing business in space with Robert Jacobson. He's actually the author of the Space is Open for Business, the book that we're giving away if you register. That's what that form is for. Check it out. He's going to be doing a discussion right now with our CEO and founder. It is the one and only Craig Fuller coming up now.